Hello everyone, I'm Aaron Moses. I'm an undergrad CSS student. Today we are going to explore one of the most powerful concepts in Python, nested loops. The overview of this session is we have introduction of nested loops, we see common uses of nested loops, and we see different types of nested loops. Loops are the workhorses of programming. They help us automate repetitive tasks, making our code efficient and scalable. But sometimes a single loop isn't enough. That's why we use multiple loops within themselves, also known as nested loops. What are nested loops? A nested loop is simply a loop inside another loop. Think of it like the hands of a clock. The hour hand moves once every 1 hour, whereas the minute hand completes a full cycle every time the hour hand moves. Here is the code for the following example. And when executed, these are the outputs of the code. Here, the inner loop completes all 60 iterations before the outer loop moves to the next hour. As you can see, the inner loop completes 60 iterations, then moves to the outer loop. Here is a real-world example for better understanding. Imagine you own a restaurant. You have 5 tables and each table seats 3 customers. To take orders efficiently, your workflow might look like this. Start at table 1, take orders from customer 1, 2, and 3. Move to table 2 and repeat. This is the Python code for the following example. When executed, we enter the number of tables, which is 5. We enter the number of customer per each table, which is 3. And then we get the order. Taking order from customer 1 at table 1. Next, taking order from customer 2 at table 1. Next, taking order from customer 3 at table 1. And so on. We go from table 2 to table 3 to table 4 to table 5. Moving on. The common uses of nested loops. We can use nested loops in various ways, but the most common uses are printing patterns, working with multidimensional data, and generating all possible outcomes. Coming to the first case, printing patterns. Nested loops are widely used to create text-based patterns like a pyramid. Here is an example code. And executed. We enter the number of rows to print, let's say 6, and we get 1, 2, 3, 4, 5, and 6. We get 6 rows of stars. Next, the inner loop controls the number of stars, whereas the outer loop determines the number of rows. Coming to the second case, working with multidimensional data. Here is an example code for the second case. A matrix is a list of lists where nested loops help us access its values. Here we create a matrix, an empty list, which is named as matrix. We enter the number of values for the matrix, the outer loop, and then the inner loop, and then we print the matrix. Running it, the number of values in the matrix. We enter the number, and then we get the matrix. Nested loops traverse each row and each element within a row efficiently. Hence, nested loops are very useful while entering values into a spreadsheet or a matrix. Coming to the third case, generating all possible outcomes. Nested loops are used in brute force algorithms like cracking passwords or generating possible character combinations. Here is an example code for it. Running it, we enter a word cat and we enter a value. You can see the first letter of the word cat and 0 concatenated and then followed by C1, C2, C3, C4, C5, so on till C22. And then we go to the second letter of cat, which is A, which gets concatenated likewise till A22. Then we go to the third letter of the word cat T, which follows the same pattern. This technique is used in AI algorithms, security testing, in game development, etc. Performance consideration. While nested loops are powerful, there are cons while using this. For example, let's consider a triple nested loop. This is a this particular program takes forever to end. Why, you ask? Because this runs a billion times. For instance, let's take each iteration takes a millisecond to execute. This whole program would take around 11 days to complete. Now, how to optimize nested loops? We have three ways to optimize nested loops. We use break and continue statements to exit loops early, use list comprehensions wherever possible, use efficient data structures for now. Nested loops also work with while loops. Here is a small example code for it. Here I is initialized to 1, and the while loop checks for if I is less than or equal to 3. If it's less than or equal to 3, it enters the loop, resets the value of j to 1. Again, there's another while loop which checks if the value of j is less than or equal to 2. It prints the current values of I and j, increments j by 1, and checks the condition again as long as it's false, and then comes back out of this second while loop, increments the value of I by 1, does the whole process again. The output of the following program is as such. This behaves similarly to nested for loops but allows more control over our conditions. Conclusion: the nested loop is indeed very powerful while coding in Python. They are in fact game changers in programming, allowing us to handle multi-dimensional data, generate complex patterns, simulate real-world scenarios. However, they must be used wisely to avoid performance issues. As you advance in Python, you'll find that reducing nested loops through clever logic or optimized library is a key skill to master. The final thought of the video is next time you see a matrix, a game board, or even a restaurant with tables and customers, think about nested loops working behind the scenes. Thank you for your time, and I'd love to answer any of your questions down in the comments.